Hi everyone, this is Mrs. Jackson. I'm making this video to support our projectile motion in quadratic project work. So what we're going to be doing is taking some videos of projectiles in motion, and we're going to extract still photos from those videos. In this video, I am going to show you how to take those still photos, import them into Desmos, and use them to perform quadratic regression. In other words, model the projectile motion's path. All right, so the first thing we're going to do to get started is open Desmos, D-E-S-M-O-S, and just like when we were in class using Desmos, you're going to click on the graphing calculator, and this is the standard default screen. You have your digital graphing paper on the right, and you have your input section over here on the left. All right, so in the classroom, when we were working on the baseball problem, we clicked on this plus symbol here, this plus button, and we imported or inputted a table. We're definitely going to be doing that again, but not yet. So the first thing we're going to want to do is import our photos. Now, for the purposes of instruction, I'm only going to put in 3 photos, but as I've outlined in the project handout, I want you to be using at least 7 positions, if not more, depending on how long of a distance that is in your frame of your video. So I'm going to show you 3. All right, so the first thing we're going to do is hit the plus button, and I'm going to hit image. Each time we want to add a new image, we're going to click on subsequent rows and add another image. Okay, so I have 3 images, and the first one is the ball at the starting position. I've got another image somewhere in the middle, like maybe near the vertex, but it wasn't the vertex, and another photo at its conclusion. Now, I kind of want them to be in order, and you'll probably, like me, input these out of order, and so I just want to show you how to fix that. So my first position is frame 1, my last position was frame 7, and I've got this one out of order. So all you need to do is just click and hold somewhere over here, click and hold, and then just kind of drag it in the order that you want. All right, so let me just show you that whatever photo is last, in my case it's called frame 7, you see on top. All of these photos are perfectly overlaid on top of each other like puzzle pieces. And the one that's on the top is the one that you can see. These circles over here, whether it be a function or a table or a photo, these circles over here are like on-off buttons. So I can turn this off. I didn't delete the photo, I just turned it off. And you can see my frame 6 here is on top. Or if I turn that off, you can see that my frame 1 is here on top because these are turned off. Now, I don't really like my frame 6 that I picked. I'm going to choose another one. I didn't realize that was so far over to the end point, so I'm going to choose something more in the middle. Maybe frame 4. All right, so I'm going to drag that up over my frame 7. And I don't really want 6. So if I actually want to delete the photo, I'm going to click this X. All right, so now I have 3 photos here. I'm going to turn them all off except photo 1, the initial point. Now, our goal here is to scale the photo so that the dimensions, so it lines up with the scales on the graph paper and that they're meaningful. So our first goal is to scale those photos, and our second goal is to translate, in other words, move those photos so that we can read things easier on the axes. So I recommend strongly that you scale the photo first and then do the translation, okay? Notice that all the photos come in with a center at the origin, okay? 0, 0. My case, my photos came in with a width of 10 and a height of 5.6. Yours might be different. They probably will be different, okay? But they'll all be the same, and they need to be all the same, okay? So that we're modeling our projectile. All right, so as I said, first is first, I want to scale the photo. And I didn't think ahead. I didn't use anything to define the dimensions in my film, but I do know that this student, I went back and found out that this student is 6 feet tall. And so I'm going to use him as my yardstick. But when you do your filming, you're going to have a yardstick directly in the film. And you're going to use that. A yardstick is 3 feet long. And so you're going to use that as your scale. All right. So I want to proportionately scale these photos. Excuse me. Now, I don't want to mess with this wrench. In class, we use this wrench to change the scales. If I do that right now, it's going to distort my photos because these photos are basically pasted right down on the paper, if you will. So I don't want to modify the wrench, although I can zoom in and out with the flywheel, or in your case, the touchpad, and everything will move proportionately. What I'm going to do is I'm going to multiply both the width and the height of my photos by a scale factor. And I'm just going to choose S as my variable. So I'm introducing a variable. I want every one of those photos to be scaled by the same scale factor for accuracy. Now, anytime, so as I've written this, that scale factor is multiplying the width, it's multiplying the length or the height. Every time you introduce a variable in Desmos, it's going to ask you if you want to add a slider. And it asks us in all 3 of these rows, and if you just click one of them, it's applicable to all 3 because I've used the same variable in all 3. Now, I know I want to scale this up. This student on my scale right now looks like, I don't know, he's 1.5 plus, I don't know, maybe 3. So he looks like he's 4.5 feet tall. If I read it on the scale, I know he's not, he's 6 feet. So I know my scale factor is not going to be negative. It's going to be positive. I want to enlarge these photos. So click on the -10 or the +10. Every slider comes up as -10 to +10. And so I know I want to be bigger than 0. I don't know how much though. I'm going to go maybe, I'm going to try 3. I'm just guessing here. But I do want to fine tune it. So I'm going to go maybe 1/1000th, just like we did in class when we were modifying that A in our quadratic function. So hit return. It's at 1. The default position, anytime you add a slider, it's at 1. So my photos haven't changed in size because I'm multiplying it by the number 1. All right, so I'm going to try to see if I can make him close to 6 feet. And I'm going to have to go back and modify it. So right now is, well, I'm going to go in the middle of his feet. So he's at -4. And I want that, if I wanted him to be 6 feet, that would mean his head is at 2. So he's a little bit more than that. I'm just going to modify it as close as I can get it for now. I mean, I know I'm going to have to go back and adjust it. All right, so for now, we'll let it sit there. Now, the next thing is I want to move all of these photos over to the right and up. I essentially want the initial position of the projectile, in this case a basketball, to be on the y-axis. And for me, I think I'm going to center it on the y-axis, okay? So I'm going to be moving over, well, almost 5 units, it looks like. And I'm going to be going up, okay? Because I want maybe his feet to be at the origin, near the origin. So I'm going to introduce 2 more variables, and I'm going to use that as the center. So I'm going to move this center. Now, the first go of this, I chose A and B. That was wrong because A is, remember, that's our vertical stretch or shrink in our quadratic function. That's the variable used for that. So we can't use A. So use some variables here. I don't know, whatever you want to use. Maybe I'm going to use M and N. But of course, I want them all to be the same, M and N. Okay. Every time we introduce a variable, Desmos is going to ask you if you want a slider. In this case, I do. The standard position, you can see our photos did jump. They went up and they went to the right because the standard position on sliders is 1. So basically, we just told the program to move over to the right 1 and up 1. I know I want to move to the right and up, so there's no sense having a negative scale here. So let's make that a 0, and I don't know, maybe 5. I don't know. We might have to play with this a little bit. 0 and 5. I do want to have a pretty fine tune on that step. Maybe I'll go 1/100th. And see where that takes me. So I'm going to start with M because that's in the X position. So I'm moving over to the right, and I want to move up. So I kind of want to get his feet maybe the center there. By the way, that is a source of error. To kind of get centered, and his head is close to 6 feet, just under. So I'm going to go back to my scale factor and maybe just up that just a smidgen. And you're going to have to iterate this a little bit too. All right, I'm really trying to make the center of that ball right on the y-axis, and I think I'm as close as I can. Now, as I said, this student is my yardstick. You're going to be doing this modification with your yardstick, okay, and try to make the scales meaningful. But I'm pretty happy with that now, okay? All right, so now we want to start to put our table in so that we can perform our quadratic regression. Now, in class, when we did the baseball problem, we just had a set of data that we were entering into the table. For our project, we're going to have to find the data, create the data. So again, I'm going to use some variables because I kind of want to make a pointer, like a little dot that I can move around with the ball and pick off some coordinates that I can put in my table. And so I'm going to use 2 more variables. I can't use A or B, so maybe I'll use, I don't know, let's say P, comma L. And I am going to add a slider. Now, in class, I showed you how to, actually, I'm going to put a label on it. Do I want a label? Yeah. So if you click on that label, it's going to give you the coordinates. And of course, sliders are always starting at 1, 1. So that's why our point is at 1, 1. Now, this point happened to come up purple. I'm going to just press and hold here on the circle to see if we want to stylize that. Just pick a color that looks more noticeable on your background. I think the green might look a little bit better. All right, so I'm going to try now. We probably do need negative numbers on our scale, and we need a fine-tuned scale. So let's give this, yeah, I think I'm going to keep it negative 10, 10, and maybe 1 100th on both of them. There's no perfectly right or wrong answer. You just have to see what you see. Now I'm going to zoom in here with my flywheel. You're going to be using your touchpad. And I'm going to try for each of my points to put that pointer, that tracer, if you will, in the center of the ball to the best of my ability. So I've got to go left. Well, I put the ball right on the axis. So yeah, I'm a little bit under. I'm not quite center, but I'm going to start to create my table. So I'm going to go down another row. And now, just like we did in class, you're going to hit that plus button and the table button. And I'm going to start recording my data. So for X, my initial position is 0. For Y, I'm going to use maybe 2.4. Okay. All right. Zoom out. Now, I'm going to go turn on my second photo. Put that at the top. I don't know why when I click that, it doesn't show up. Okay, there it is. So now I'm going to go back to my tracer point here, which is PL. Press and hold. It's a little bit blurry, but I think I can still do it. I'm going to, let's see, I am going to move up. I think I probably even should have used 1 1,000th for the tracer for accuracy because I'm having trouble getting this exactly where I want to be. But for the purposes of moving on here, the tracer is saying 3.9 and 5.8. So get that into your table. 3.9 and 5.8. And the last photo, I'm going to turn on now. Because I'm only using 3 data points, my quadratic is not going to be the best model. Okay, so I'm all the way over to this ball. Oh, I'm all the way over at the 10, and that wasn't enough. So I'm going to slightly modify the max from 10 to maybe 12 just because I'm going to need to move over a little smidgen to the right. And I'm going to zoom in over there for accuracy purposes. All right, I'm going to call it there. I'm going to say 10.3 and 5. So get that point into the table. All right, so I'm only going to use 3 points. You're going to have a table of 7, 10, maybe even more points based on your video. All right, so just like we did in class, underneath the table, we're going to start to do our regression on the next row. And I do want vertex form, although you can do both forms. There's some interesting data for both forms. So vertex form is y equals our stretch or shrink factor a times x minus h. H is the x coordinate of the vertex. We want to raise this to a power of 2, and you can do that with the shift 6 button, or you can use this calculator down here, and plus k. And it's going to ask us again for sliders. We don't want the sliders. We want the computer to be doing the regression for us. We do have an error right now with the exclamation point, and the two forms of error are going to be this equal sign that must be replaced with the tilde that's in the upper left of your keyboard. And the second thing is the labels have to match. So we have x sub 1, y sub 1 in the table. These have to match. So you just go after the y and put a 1, and it'll automatically make it a subscript. Same thing with the x. And there is our regression. So remember, the computer does the best that it can be done, much better than anything we could do. And so the model is automatically graphed on the paper. And we have our values for our quadratic in this case. Remember, a is very powerful in a quadratic function. So you want to be going out at least, I would say, 4 decimal places to the 10,000th. So in this case, this would be negative 0.0968. And our x and y coordinates of the vertex, we can maybe go to the 100th. So this model is saying that the x coordinate is 6.45 and the y coordinate is 6.43, kind of symmetrical there. All right, so in this video, I showed you how to input still photos into Desmos. I showed you how to use sliders to scale those photos proportionally and to translate those photos. I then showed you how to create a point used as a tracer to pick off locations of your projectile and put those coordinates of those points into a table and perform quadratic regression. I hope this video helps. Thanks for listening.